Good afternoon, dear conference members. My name is Dufay Najim Abdulaziz. I'm a doctoral student at the International University of Agadir, and today I will be presenting my paper based on optimal maintenance strategies for wind turbine gearbox gear trends, considering oil filtration interval. So let's move to the presentation. Yeah. So as I said, the paper is on optimal maintenance strategies for wind turbine gearbox gear trends, considering oil filtration intervals. So the presentation plan is as follow. Yeah. First of all, we have literature review. Then we will move to problem definition, maintenance strategies, numerical example. Then we will finish with conclusions and perspectives. So literature review. Many papers have allowed us to understand the world of maintenance and to see the research that already exists. Then we can cite the paper of Genduli and Mifdal. In this paper shows that industries adopt diversified energy strategies to stabilize costs and reduce carbon intensity. So also the paper of Afif and Zeng and the paper of Zeng and Al focus on developing optimized and realistic maintenance policies for wind turbine components using advanced modeling. So we can also add the paper of Zeng and Al in 2020. In this paper used as a failure function a variable distribution to which is added the impact of the wind speed thanks to the Cox pH model, which makes this function more realistic and dynamic. So all these papers have allowed us to define our problem. So in our case, when there is a worrying state of contamination of oil in the gearbox gear trends, the wind turbine production is automatically reduced and the system operates below a critical threshold. Then an imperfect preventive maintenance action is carried out to reduce this contamination. So after this contamination decreases, the wind turbine system returns to normal operation. So then we modeling two type of maintenance strategies. So the first strategy is an optimal renewal. We will determine the optimal period T start for replacing the gearbox gear trends by minimizing overall maintenance costs. uh, these costs are cost of production lost, cost of filtration, logistics cost, and cost of renewal, while ensuring reliable operation and optimal energy production. Our decision variable is T start. So the expression for the total expected cost is composed of, in the first strategy, the average cost of renewal, the cost of production lost and filtering during a renewal cycle, the renewal action related logistics costs, and finally the renewal period. So as I said, we have renewal action related logistics cost plus the cost of production lost and filtering during a renewal cycle. All these expressions are divided by a renewal period. So in the second strategy, we will do an imperfect preventive maintenance. We will determine the optimal number and start of imperfect preventive maintenance actions to be performed before renewal, and we will also determine the optimal preparation period of the maintenance actions by minimizing overall maintenance costs that are cost of production lost during filtering, cost of filtering, and cost of the imperfect preventive maintenance action, and cost of renewal, while ensuring reliable operation and optimal energy production. Our decision variables are in start and logistic preparation start, LP start. So in this second strategy, the expression of the total expected cost is composed of the sum of production lost cost, filtration cost, and renewal cost, and the cost of production lost and filtering during a renewal cycle, the costs of planned preventive interventions, and finally the average duration of a renewal cycle. So as I said, we have the cost of production lost and filtering during a renewal cycle, plus the costs of planned preventive interventions, plus the sum of cost of production lost cost, filtration cost, and renewal cost. And all these expressions are divided by the average duration of a renewal cycle. So then we will move to numerical example. In this part, we use as a logist as a logistic mathematica. So we put data related to in the first strategy, which is to determine the optimal renewal. We put data related to failure rate and data related to maintenance, and we put also failure rate expression and the expression of total expected cost, and then we obtain that the obtained optimal renewal period is the start, which is 2010 weeks. So after 2010 weeks, we will replace the gearbox gear trends. So in the second strategy, we put also data related to failure rate and data related to maintenance, and then we put also the total expression cost, the total expected cost expression, and we obtain that the optimal solution recommends performing 6 imperfect preventive maintenance cycles before a renewal and choosing the interval, which is 10 hours to 13 hours, as the optimal period for logistical preparation. So conclusions and perspectives. As a conclusion, we can say that the two strategies developed offer a decision-making methodology that reduce total maintenance costs. We can also add that the second strategy is more cost-effective than the first strategy with a with a considerable reduction. We can also add the second strategy also allows for better planning than the first strategy. In the perspectives, we can say that we can improve the mathematical models even more robust by adding costs such as logistics penalty costs, cost of the monitoring system also, and so on. So we can also improve strategies to the two strategies throughout predictive maintenance models with artificial intelligence for wind turbine gearboxes. So in this page, we can see all the references that we use to develop and to modeling our strategy, our two strategies. So this is the end of my presentation. It is an honor for me to have been able to present this work. So thank you all for uh, receive our paper.